Thank you very much. Thanks for the privilege. And I welcome you again to the second clips of our elementary set theory. As we have said previously, we have said that set is a collection of well-defined elements. A collection of well-defined elements. Now, and we gave some examples where we said we can consider a collection of counting numbers or whole numbers. We also looked at a collection of all the alphabets. Now, today we are going to continue with set notation. Set notation. We are going to consider set notation. But before I continue with this, I will want to give a precise definition, as we have also done in the other clip on set theory. We have said that sets can be said to as a well-defined collection of elements. Sets can be seen as a well-defined collection of elements. So, as far as this class is concerned, we will ensure that every collection that we are to look at must be well-defined. Now, set notation. It is a common practice in our society that communication can also be done through symbols, signs, alphabets, codes, etc. in a way of representing an item. This, however, enables the item to be properly identified by way of name, position, or size, or as the case may be, for distinction among others. Now, as I am here, assuming that we are 3 in number or 4 in number, and so you want to refer us to someone that is outside here, what do? Because I have an identity, which is my name, you can be anywhere, at any point, any location, and make reference to me because of my identity. That is what we are likely to do here. And in the same manner, I'm here to tell us that this practice is also common in mathematics, the act of assigning an arbitrary element to things. Now, in set theory, we are used to assigning uppercase letters, capital letters, for representing or denoting a set, such as A, B, C, and so on to Z, because they are countable. We use these alphabets, these uppercase letters, to represent a set. So if you want to make reference to a particular set, we say let A, where the A must be capital, or B, be so collection. Whereas its elements, the members of that set, if they are alphabets, they must be written in smaller cases, such as A, B, C, so on to Z, in smaller cases. Now, let's consider some examples. Let's consider a set, say A. Let it be a collection of whole numbers up to 5. Let it be a collection of whole numbers set up to 5. A set A, therefore, will be a collection of whole numbers up to 5. 1, 2, 3, 4, 5, up to 5. This is how we write it. So if we're talking about these elements, it's just for us to talk about A. So once you talk about A, you know that you are talking about these collections, these elements. In like manner, we can also say, let's consider a set B where its elements are all the English alphabets. Then that set will be B will be equal to all the English alphabets. So we say A, B, C, dot dot to Z. To Z. We can also say, let's consider another set. These are all examples of sets. We can also say, let's consider another set that consists of a collection of vowels. And let that set be D or E. E. Therefore, that set will be collection of all the vowels. So we say A, E, I, O, U. So you can now see that we can talk about these collections, these separate collections, by not necessarily calling them, but by just referring to this denotion, A. These that we are using denote. So anytime we're talking about A, you know that we're talking about these elements. Anytime we're talking about B, you know that we're talking about these elements, as the case may be. But there are some things that I will want us to also consider here in this presentation that we have made. We can see in like set A here that the elements that are in this set A are all separated with commas. They are all separated by commas and enclosed in a bracket. And the bracket is not just every bracket, but a curly bracket. In like manner, for that of B, its elements thereof are also separated with commas and enclosed in a bracket. And the same thing to that of E. So we are here to tell us that, or to say that, for a set to be properly stated, its elements must be separated with commas and enclosed in a curly bracket. So in other words, if I choose to write A equals to 0, 1, 2, so on to 5, we might not recognize this as a set, because yes, the elements are separated with commas, but not enclosed in a curly bracket. Let's consider another one, say E, and we use these other brackets and say A, E, I, O, U. This will not also be considered as a set, because yes, its elements are separated with commas but not enclosed with a curly bracket. It is only when the set is presented in this manner that we say it is called a set. It's also my pleasure to tell us here that the manner in which a particular set is arranged does not really matter. The manner in which a particular element, the set, the collection are arranged, the elements are arranged, does not matter. How do I mean? Like if we consider set E, and we consider another set, say Q, and let Q be E, O, I, A, U. If we consider these two sets, you see that A is here, A is also here. E is here because it's a collection of all the vowels, this one. And this one, if you look at it properly, you can also see that it's also a collection of the vowels, the vowel letters. A is here, A is also here. E is here, E is also here. I is here, I is also here. O is here, O is also here. U is here, U is also here. So in this sense, we are saying that these two sets are the same. They are equal. They are the same. So the manner in which the numbers are arranged does not really matter. If I want to say, let's concentrate on a set of whole numbers up to 5, as we have here, we can also choose to write 1 first. We can choose to write 2 or 3, either of these elements first. It doesn't matter. So the order in which the elements are arranged does not really matter. Now there is another thing I would want us to also note here, and that is, let's consider a set, say A, and we have its elements as 2, 4, 6, 2, 8. 8. Now you can see that this collection here is well defined. Well defined in the sense that they are even numbers less than equal to 8. These are even numbers. The set A is a collection where its elements are even numbers less than equal to 8. But then you can see that 2 here is repeated. Let's consider another one. Sorry. Say 6 before this. You can see that we have 2 here. We have 2 here. We have 6 here. We have 6 here. This presentation in terms of set theory is not really proper. Not proper in the sense that no element is expected to be repeated. Yes, they are all well defined. Well defined in the sense that it's a collection of even numbers less than equal to 8. But then, its elements thereof here are equal. So what we are supposed to have is a collection 2. If our collections are even numbers less than equal to 8, then it's supposed to be 2, 4, 6, and 8. So there is difference between these two. This presentation is well defined because we said set is a well defined collection of elements. So this one here is well defined. Now I also wish to bring to our notice that between set A here and set B here, you can see that there are the elements that are in set A are not contained in set B. So there is also a language or a presentation that can be made in respect of that. Now here we have A as a member of set B. A is contained in B. C is also contained in B. Z is also contained in B. This statement you can write as A is contained in B. C is contained in B. Z is contained in B. In like manner, if you want to concentrate on the whole numbers that are up to 5 here, you can also say that 0 is contained in A, in set A. 3 is also contained in set A. In set A. In set A. Now, in same manner, we can also negate this statement. Here we have A is contained in set A. Yes, it is in set B. Yes, it's true. But A is not contained in A. 1 is not contained in B. that is true, this we can also write as A is not contained in A. C is not contained in A. And in like manner, 3 is not contained in B. And 0 is not also contained in, or is not an element of set B. So this one is a member or is an element of this, while this one is the negation of that statement, is not. Now let's consider a few examples to see if we get the concept. I want us to concentrate on a set, say Q. Let it be a collection of all negative numbers less than 5. Let's consider a set, say Q, and let it be a collection of all the numbers, negative numbers less than 5. Q be a collection of all negative numbers less than 5. So if that is true, we have 6, negative 6. Negative 6 is less than 5. We have negative 7, negative 8, and so on to negative infinity. We can also consider another set where we say, let us consider all negative integers that are greater than equal to 2. Let's consider a set, say E, where its elements are negative integers less than equal to 2. If that is true, we are expecting a set of this form, negative integers where its elements are greater than equal to 2. If that's true, we have negative 1, which is greater than 2, negative 2, and because we said they are also equal to, so negative 2 will also be included. So, in other words, we are saying that when a presentation of this form is before you, you just know that we are dealing with set theory. Know that we are dealing with set theory. So conclusively, for a presentation to be called a set, its denotation must be capital, and its elements, if its alphabet, must be in smaller cases, and all the elements in the set or of the set must be separated with commas and enclosed in the bracket. We have also said that in a particular collection, all the elements must be well defined. No element is expected to be repeated but once. And our presentations should not also be vague. It must not also be vague. So with this, I believe we are in order as far as set notation is concerned. Next we want to talk about is set description. Next we want to talk about is set description. Set description. Now, I am pleased to inform us that for a given information concerning sex, the information must not be misleading, especially when it does not represent a proper collection or when its information is vague. How do I mean? For a given information concerning sex or given information concerning sex sometimes can be misleading, especially when the information did not reveal if a particular element is contained in a sex or not. How do I mean? Let's go to the English alphabet for illustration. Let's consider the term E and another one, E. Note that we said sex, it must be well defined. It must not be vague. Now, these two elements that we have, these items that we have, this one is E, though it's smaller case. This one is also E, uppercase. In this context, they are the same because they are all called E. But it is also possible that these two might not be the same, depending on the information. That is why we are saying that it must be well defined. For example, if we say let's consider a collection where its elements, let's say set A be a collection where its elements are the first five alphabets. Comprising of both smaller case and uppercase. If that is true, then our elements will be A, B, C, D, E, A, B, C, D, E. Now you can now see that the statement that we have made, this collection now, is well defined. Well defined in the sense that the elements are a collection of both smaller and uppercase. So it's well defined. But if this distinction is not clearly stated, sometimes it can be misleading, and a given information can be misleading. Let me use another example again. If we are interested in, let's say, set A is a collection of people with sickness. Set A is a collection of people with sickness. Set A is a collection of people with sickness. And let's also say set B is a collection of people with HIV. People with HIV. You can now see that set A is a bit misleading. It's a bit vague. Vague in the sense that, okay, let's say B, people with HIV in Yenagoa. People with HIV in Yenagoa. With Yenagoa. Now you can see that B is well defined. Well defined in the sense that you can go to Yenagoa and fish out all the persons with HIV. Now the question here is, in these two statements, are they the same? Will the elements be the same? Now, given two students to determine the number of this set, they might come forth with different answers. Different answer in the sense that people with sickness, one living in Port Harcourt may want to go through the people with sicknesses. Someone in Yenagoa may want to go to Yenagoa and get number of people with sicknesses. Now you can see that there is the possibility that the number may vary. Now it is like that because the information is not precise, it's vague. So in set theory, what we are saying is that the information, every given information, must not be vague. It must be precise and also well defined. With this, I know you have gotten a better understanding of what set description is and set notation. So conclusively, we are saying that in this set description, all these things must be, all the elements to be considered must be well stated. They must be well defined. All of them must be well defined. They must not be vague, else the information might be misleading. Now in the other one we have said, for it to be a set, we must denote it with a capital letter. Its elements must be in, if it's alphabet, English alphabet, they must be in smaller cases. They must be enclosed in a curly bracket and separated with commas. Thank you. Let's look forward as we go on to other clips for other topics. Thank you.